Let's look at some examples of dealing with hyperbolas. So in this first one here, we're going to graph the hyperbola with this equation. We're going to find the coordinates of its foci and then the equations of its asymptotes. So to start with, I know this is a hyperbola because that's a minus. So if it was a plus, it would be an ellipse. For hyperbola, I know a squared is always first. Okay, for an ellipse, a squared is always biggest. So if this were an ellipse, the 16 would be a squared. But that's not the case here. It's a hyperbola, so a squared is whatever's first, as long as it's equal to positive 1, which it is here. So I've got a squared is 9. So then if I take the square root, I get the square root of 3. That would be plus or minus 3. And where did the 9 come from? Well, the 9 came from the x term, so that means that's how far I'm going to move in the x direction. The b squared then is 16, so b is plus or minus 4, and that came from the y term, so that's how far I'm going to move in the y direction. And since it's just x squared and y squared, my center is just 0, 0. Okay, so the center is going to be at 0, 0. I'm going to move 3 in the x direction. So 3 left and right from the center, 4 up and down. And it's really important for a hyperbola to make a box that goes through those points, a rectangular box. Okay, so we just connect these corners and make that box going all the way around. And for an ellipse, I could have also made the box, and the ellipse would have been on the inside of the box, but the hyperbola is on the outside. And what I need for a hyperbola is I need to connect the corners of the box and make the asymptotes. Didn't line up there very well. Okay, so then I make my asymptotes this way. And again, so if I look back here, then a squared was first, and that's with my x. So what I know here, x squared is also first, so that means it's going to be horizontal. So my hyperbola is going to start horizontally from the center. So I move over here, those would be the vertices. The hyperbola starts at each vertex, it goes away from the box, and then towards the asymptote. So I just draw the hyperbola away from the box and towards the asymptote. So that red graph is the actual hyperbola. The blue stuff is just the framework or the skeleton that we would have. For the foci, I need C. For a hyperbola, the foci are going to be on the inside of the hyperbola, so outside the box. The distance to the vertex is A. The distance to the focus is going to be C. So that means C is going to be bigger than A. So I would have to have C squared equals A squared plus B squared. So that would be 9 plus 25 here. I'm sorry, 9 plus 16. I was jumping to the answer. So C squared would be 25. So C is plus or minus 5. And again, remember, this is a horizontal hyperbola, so I'm going to have to move that distance from the center. So the center is at 0, 0. So to get to my foci, I'm going to move plus or minus 5 in the x direction. The y direction is going to stay 0. Right? We'd start here at the center in the graph. That 5 is how much I'd have to move in the x direction. So I'd move 5 to the left, that would bring me to negative 5. 5 to the right would be positive 5. So my foci are at plus or minus 5 comma 0. For the asymptotes, I'm going to use this point slope form, and the x1 and y1 have to be the coordinates of the center. So I'm going to plug in 0 and 0. And for the slope, I look here at where the center would be, and I look at one corner of this box, and I just count how far up and down I'm going. So as I go along this way, I'm moving 4 that way, and I'm moving 3 that way. So it's always, slope is always change in y over change in x, so that's going to be 4/3. This has a slope of positive 4/3, this one asymptote. The other asymptote is going downward. That would have a slope of negative 4/3. So I say plus or minus 4/3. And then in this case, I don't really need the zeros. Y minus 0 and x minus 0 are just y and x. So I get y equals plus or minus 4/3 x. Those would be the asymptotes for that hyperbola. Okay, now in the second example, y squared over 16 minus x squared over 9 equals 1. Again here, since it's minus, that means it's a hyperbola, so that means a squared is first. What that also is going to mean here then, my y is first, so it's going to be vertical. Okay, so a squared is first, it's going to be vertical. So a squared is 16. That means a is plus or minus 4. And that's under the y, so that's how far I'm going to move in the y direction. The b squared is 9, that's second. So b, when I take the square root, I get plus or minus 3. That's under the x, so that's how far I'm going to move in the x direction. Since it's just x squared and y squared, my center is just 0, 0. So we start at 0, 0. I move 4 in the y direction and 3 in the x direction from the center. And then I make this box. And then I connect the corners of the box to get the asymptotes. And one of the things you might notice, this box and diagonals, it's exactly the same as what I did up here in this other example. What my a squared and b squared are changed, but the 9 was with the x squared in both examples, the 16 is with the y squared in both examples, so I'm moving the same amount in x and y. The difference is, in the first example, x was first, so it was horizontal. In this second one, y is first, so it's vertical. So when I draw the graph, I start by going up or down from the center, and that takes me to these as my vertices. And then I go away from the box and towards the asymptote. So my hyperbola here goes up and down instead of left and right. For the foci, I have the same sort of consideration. My C value is the distance to the focus from the center, and the foci are always on the inside of the hyperbola. They're going to be up here somewhere. I didn't graph them up in this other example. I could have. I was moving 5 from the center, so that would be over here. That would be one focus, and then another focus would be over here. Those would be the foci. We didn't have to graph those, but we could have. I'm going to get the same sort of thing here. The C then has to be bigger than A. So if I start with c squared and a squared, well, they can't be equal. C is bigger, so I have to add something to a squared to make it equal to c squared. And so what we get here then, a squared is 16, b squared is 9, so I still get c squared is 25. So c is plus or minus 5. The difference though now is it's vertical. So to get the center starts at 0, 0. So to get to my foci, since I'm going vertical, the x-coordinate stays the same. The y-coordinate starts at 0, and then I add or subtract 5. So that's just going to be 0 plus or minus 5. Those would be the foci. And again, we don't necessarily have to graph those, but if I move up 5 and down 5 from the center, I'm at these points here. For the asymptotes, we use point slope form, and I take this center and I use that center to get x1 and y1. And then for the slope, I start at the center and I go to one of the corners of the box and I just count how far up or down I'm going and how far left or right I'm going. So up 4 and over 3, change in y over change in x, I get plus or minus 4/3. So we get exactly the same asymptotes that we had in the first example. Because of the relationship here, we see that both of these hyperbolas have the same underlying structure, the same sort of, this is sometimes called the fundamental rectangle, and these asymptotes in the same center. They definitely have a relationship, and their equations are very similar. It's just here I have x squared over 9 first and y squared over 16 second. Here I switch them. These parabolas are sometimes called conjugate parabolas. I'm just sort of changing the order of that subtraction. Conjugate hyperbolas always have the same fundamental rectangle and the same asymptotes. They're just going different ways. That's also why for a hyperbola, remember, the line segment going between the vertices is called the transverse axis. So on this first one, the transverse axis is horizontal. On the second one, the transverse axis is vertical. Remember, though, then we call the other axis the conjugate axis. So this is the transverse axis up here on the first one. This is the conjugate axis. The conjugate axis becomes the transverse axis for the conjugate hyperbola. So they just sort of switch like that. Okay, let's do a couple examples where we're not centered at the origin. So first of all, this is a minus. So that tells me a hyperbola. That means a squared is first. If this were an ellipse, a squared would be bigger. So in this case, a squared is the 16. Also, that means x is first. So x is first. So that means it's going to be a horizontal hyperbola. So my a squared is 16. That means a equals plus or minus 4. That's under the x. So that's how far I'm going to move in the x direction. My b squared is 4. That's in the denominator of the second fraction. So b is plus or minus 2. That's under the y, so that's how far I'm going to move in the y direction. Now what I've got here is x minus 2 squared and y plus 1 squared. And so what that means, my center, I take the opposite. I think what would make those equal to 0? So 2, negative 1 is going to be my center. So I go to 2, negative 1. That's the center for this hyperbola. I look at A, I'm supposed to move 4 in the x direction. Start at this center, don't start at 0, 0. I count over 4 to the left and 4 to the right. Oh, this graph's going to be a little off here. I'm not going to have a lot of room. Y, I'm going to go up 2 from the center and down 2 from the center, right? So I'm just using these values from A and B that I have over here. Now I make the box, this fundamental rectangle. I just connect that all the way along. Once I have the rectangle formed, I'm going to connect the diagonals. That's going to give me the asymptotes for this graph. Okay, since it's horizontal, I'm going to move from the center right here. I'm going to move left or right to get to the vertices. So my one vertex is going to be over there, my other vertex is going to be here. The hyperbola always starts at the vertex, it curves away from the box and along the asymptote. So I'm sort of running out of graph over here, but that's okay. So that's what the hyperbola would look like. Now I'm supposed to find the coordinates of the foci. So for the foci, I need to look at the relationship between a squared and c squared. And what I know is for a hyperbola, a is this distance to the vertex, c is going to be to the focus, c has to be bigger than a. So if I start with c squared and a squared, they can't be equal. C squared is actually bigger, so I'm going to have to add something to a squared to make it work. So a squared is 16, b squared is 4, so that means c squared is 20. So c is plus or minus the square root of 20. That's square root of 4 times square root of 5. So simplified, that's 2 square root of 5. This is horizontal. So I would start at the center, which is 2, negative 1. But since it's horizontal, I'm going to have to change the x-coordinate, right? I'm going to have to move left or right to get to the foci. So I'm going to start at this x-coordinate of 2, and I'm going to move 2 times the square root of 5. So the way I write that, I just say plus or minus 2 square root of 5. And the y-coordinate stays the y-coordinate in the center. Don't put 0 down. Right? We start with 2 for my x-coordinate. Negative 1 is going to be my y-coordinate. So those are my foci. For my asymptotes, we've got y minus y1 equals m times x minus x1. What's important again, the asymptotes go through the center. So this is the point I want to use for x1 and y1. So y1 is negative 1, x1 is 2. You see where I got those from? I just came up here. 2 became my x1, negative 1 became my y1. What about the slope? Look at the center, find one of the corners, and just imagine tracing out that path. So I'm going up 2, and I'm going over 4. So the slope is change in y over change in x, so 2 over 4, plus or minus. If I simplify this a little, we get y plus 1, right? Negative minus a negative becomes a positive. We get 1/2, and then the x minus 2, and those would be the asymptotes. All right, let's see, one more here. Again, that's a minus, so that means this is a hyperbola. For a hyperbola, we always have a squared first. What we've got here then is y is first. So that means it's going to be vertical. Okay, we said a squared is first, so here a squared is 9. So A is plus or minus 3. The 9 came from the y, so that's how much I move in the y direction. My b squared then is the 4. When I take the square root, I get plus or minus 2. And that's how far I'm going to move in the x direction. I'm starting with x plus 1 squared and y minus 1 squared. So that means my center is going to be negative 1 comma 1. Be sure you use the x coordinate for x, right? Look at the x term to find the x coordinate. It's always the opposite. And the y term to find the y coordinate. Right? Up here, the x was first, so it just stayed first. Here, x is second, so that second one has to become first for the center. Right? X always comes before y, but in this equation, y is before x, so I have to switch that. So I graph the center, negative 1, 1. That's up here. A was 3. I'm moving plus or minus 3 in the y direction. So that's there and there. I'm moving plus or minus 2 in the x direction. All right, so I've got my center, I've got those points. I'm going to connect and get the rectangle, this fundamental rectangle, and then connect the corners to get the asymptotes. Alright, so there's my rectangle. I connect the corners. Be sure you stick to the center, right? You were not thinking about 0, 0 here. This has been moved somewhere else. And this is a vertical hyperbola, so I have to go from the center up here. That's my vertex. That's not what I wanted. So that's my vertex, and then I've got another vertex down here. And the graph then has to go away from the box and towards the asymptote. So something like that. To find my foci, well, we're always starting here. C squared has to be bigger than A squared. So C squared here is going to be 9 plus 4. So that's 13. So in this case, C is just plus or minus square root of 13. And there's nothing I can do to simplify that. This is vertical. So my center, you know, we've said starts at negative 1, 1. So to get the foci, vertical means I have to change the y-coordinate. So the x-coordinate stays the same. The y-coordinate starts the same, 1, but then I have to add or subtract the square root of 13. So those would be my foci. To find the asymptotes, we start with point slope form. Y minus y1 equals m times x minus x1. Remember here, this is where my x1 and my y1 are going to come from. So y minus 1, x minus negative 1. And for the slope, I just imagine going to the center and one of the corners, and I'm moving up 3 and over 2. So the slope, change in y over change in x, 3 over 2. But there's 2, one with positive and one with negative, so plus or minus 3 over 2. And I probably would want to simplify the x parentheses there and make it x plus 1. Okay, so that's how graphing these hyperbolas works. Just one other sort of situation to talk about. We might start with an equation of a hyperbola that looks like this. This is not in standard form. What we need to do to put it in standard form is we're going to put the y stuff together, the x stuff together, and move the constant to the other side. So I'm going to move this 3 over to the other side of the equation. And I'm going to rearrange the y's. Since it's y squared minus x squared, I want the y stuff first. So I'm going to have 4y squared, and then I'm going to put the y with it, minus 16y. And then I'm going to get minus x squared, and then the plus 6x, and I've moved the 3, so it's just going to be equal to negative 3. Now, when I'm completing the square with x and y, it's important that what's in front of my squared terms is 1. So here it's not a 1, it's a 4. So I have to factor out a 4 from the y stuff. Okay. Now, with the x squared, it's not really a 1, it's really a negative 1 in front of that x squared. So I have to factor out a negative 1 from the x stuff. So negative 1 times x squared, but then if negative 1 times what is positive 6, that has to change to a negative 6x so that this all works. Notice, what happens if you distribute right now? 4 times y squared, 4 times negative 4y, negative 1 times x squared, negative 1 times negative 6, positive 6x. So nothing's changed here. It really is the same. To complete the square now, I take half whatever's in front of my variable by itself. So I've got 4y. So I'm going to take 1/2 of 4, and then I'm going to square that. So that's going to give me 2 squared, which is 4. So I'm going to add 4 over here. And then with my x stuff, I'm going to take 1/2 of the 6 and square it. So that's going to be 3 squared, which is 9. Now again, you could argue, well, wait a minute, isn't it really negative 6? So this should be negative 6 here, which would be negative 3. Yeah, but negative 3 squared is still 9, so that doesn't really matter. So here I'm going to get minus, I don't have to put the 1 there. I get x squared minus 6x. And I'm going to say now plus 9. And here's the tricky part. Whatever I do to one side, I have to do to the other side. But be careful. Here you think you added 4. But that 4 actually had to get affected by that 4 in front of the parentheses. And here, again, maybe I want to do that 1. That negative 1 has to get multiplied. So I thought I was adding 9. I was really adding negative 9. So that's, essentially, I could say plus, and then it's negative 1 times 9. So what I've got here, I'm going to start factoring this. So y squared is y times y. The 4 was 2 times 2. To get negative 4 in the middle, they'll both have to be minus. The x squared has to be x times x. The 9 came from 3 to 3. To get negative 6 in the middle, they'll both have to be minus. And what I get here then is negative 3 plus 16 minus 9. So I can write this as squared and squared. And over here I just get 4. What I want that 4 needs to be a 1. So I'm going to divide by 4. But that means both parts here get divided by 4. And when I divide, 4 goes into itself once. I get y minus 2 squared. Now, I don't have to write this, but I can say over 1 if I want. Then I get minus x minus 3 squared over 4 equals 1. And that now is in my nice form. So I would have here that a squared is 1, b squared it's 4. That's under the y, so it's vertical. And my center is going to be at 3, 2. Right, we have to look to x for the x-coordinate and y for the y-coordinate. You wouldn't have to do this stuff at the bottom. I'm just sort of connecting that back. This is the equation in standard form.